This is May 2015, paper 2, time zone 1, question number 9, and this is a section B question, which the first part is there, all about statistics and about the normal distribution. So we've got a company making yogurt pots presumably, and their yogurt pots have an average, a mean of 260 and a standard deviation of 6, and they are normally distributed. So we should write x follows a normal distribution, 260, 6 squared. 6 is standard deviation and the variance is 36. A container which contains 250 ml or less is underfilled. So if we think about what our normal distribution would look like, always the same shape, 260 in the middle, anything less than 250, underfilled, and we want to know what's the probability of that happening. What's the probability x is less than 250? So this is a calculator paper, as you would expect, and in order to answer this question, you need to use your calculator. In the distributions menu, you will find normal CDF. Remember, the C stands for cumulative, and with the normal distribution, we're only ever interested in the cumulative value. And you type the following pieces of data in. The minus 1 times 10 to the 99 just means that you're choosing a ridiculously small. If I extended this, we're talking about a number way down here, massive negative number. So it just means it's going to include everything up to here. After you're 3 standard deviations away, that makes such a tiny difference. So you could put the number 200 in and you would still get, if not identical, then as close as an identical answer. The upper bound is important. The upper bound is this number here, 250. And then as well as that, you add in the information that we have about the distribution. The mean is 260 and the standard deviation is 6. Once you've done that, you should get the answer 0.0477, which is our probability. 0.0478, or around 5% chance of us getting one that is underfilled. The company decides that the probability of a container being underfilled should be reduced to just 2%. So they're not happy with the 5% that we got as our answer to part A, wants to get it down to 2%. They're going to keep the mean the same. Presumably they want to sell their yogurts for the same amount of money. It's still going to say it's 260 grams. But they're changing the standard deviation. Maybe they're changing the systems in the factory, maybe they're just changing the equipment that they use, but they're trying to be more consistent, more accurate. More consistency, more accuracy will mean a smaller standard deviation. And that will reduce the probability that they are underfilled. So now we've got x following a normal distribution with 260 remains the mean, but sigma we don't know. All we do know is that we want the probability that x is less than 250, so that they're underfilled, to be 2%, 0.02. So your calculator isn't designed to deal with situations where we don't know sigma. So instead what you have to do is apply the transformation, and we're going to use a different normal distribution. Z follows a normal distribution 0, 1. And our normal distribution where we don't know sigma, with our mean of 260, and we know that this area here is 2%, will correspond to a standardized normal distribution where the mean is 0 and the area is still 2%, and we can find this Z value here, which a calculator can do, and you use the function inverse norm. In the distribution menu, option number 3, inverse norm. Now the inverse norm function, when you bring it up, will look something like this. If you do happen to know mu and sigma, you don't have to go through this process with the Z, but because we only know mu and sigma is unknown, I'm going to leave it as 0 and 1. Type in the probability, the area that I do know, the 0.02, the 2%, and that will give me the Z value that corresponds to the X value that I need. So Z is this standardized one, and X is the specific one about my yogurts and my underfilled containers. So from my calculator, I get the Z value is minus 2.05. 374 Z and X are related by a formula that is given in the formula booklet and that we've seen in class. It is that Z is equal to X minus mu over sigma. But now we know everything except sigma. We have our Z value that we just calculated. We have Z is equal to minus 2.05. We have our X value that was given in the question is 250. That's what the number when they're underfilled. Those two values correspond to each other. They're both a 2% probability. And mu, we have mu, the mean is 260. So we just have to work out the standard deviation by substituting those numbers into this equation. Minus 2.05 is equal to 250 minus 260 over sigma. Minus 2.05 is equal to 10 over sigma. So sigma is equal to 10 divided by minus 2.05. I feel like I've missed a minus sign. I have done. There should be a minus here and a minus here. Do that calculation, minus 10 divided by minus 2.05, and you get 4.87 as our new standard deviation. So that's part B. So we've got our new standard deviation, which we're going to use in this question. Sigma is 4.87. If you get a negative answer for sigma, you've done something wrong. Because remember, the standard deviation is a measure of spread. It's how far things are typically from the mean. The mean is still 260, so X follows normal distribution, 260, 4.87. Container is chosen at random from inspection. It passes inspection if its volume is between 250 and 270. Find the probability of passing inspection. So we're basically asking what's the probability that X is bigger than 250 and smaller than 271, using the numbers that we had before. And that's easy to do. It's just in the stat menu. No, so the distribution menu. And it's the normal CDF again. Type something like this. I've used the answer as my sigma because it's the last thing I typed in my calculator, and I get that that probability is equal to 0.968, so nearly 97%, so it's a pretty high chance that the yogurts are going to be within this tolerance. The last part, this is where the binomial is going to creep in. A sample of 50 containers is chosen at random. Find the probability that 48. So I'm doing 50 samples, so let's call this Y, It's going to be a binomial distribution because I'm doing the same test 50 times. And the probability we just worked out, nearly 97%, probability that one of the yogurts passes is 0.968. So the question is, what's the probability 48 or more of the containers pass inspection? The probability that y is greater than or equal to 48. But because of the way my calculator works, when it does binomial probabilities, it only calculates them from the left as it goes. So I'm actually going to calculate 1 minus the probability that y is less than or equal to 47. In the distribution menu, because it's an inequality here, I want to use binomial CDF, the cumulative version. So that's in the distribution menu, binomial CDF.